Dear students, welcome to my channel. In our data structure and algorithm tutorial series, today we will discuss stack. Okay, so as you know, stack is a linear data structure. Okay, so myself Niladri Shekhar Pal, I am working as an assistant professor at Computer Science and Engineering Department, Greater Kolkata College of Engineering and Management. So what is stack? A stack is basically a linear data structure, okay, in which data items are inserted and deleted at one end only, rather than in the middle called as, okay, and where it has been inserted or deleted is called the top of the stack. So all stack is basically a linear data structure, okay, and the elements inserted and deleted from top of the stack, okay. Next, stack basically follows LIFO, that is last in first out, okay, or FILO, that is first in first out. That means the element which have entered last will be deleted first. Okay, suppose you can take a box of Cambis ball. Okay, from where you the last ball we have entered. Okay, that ball will be deleted first. Okay, so stack is basically a restricted data structure. That means we cannot insert or delete the elements of in stack from anywhere. We can insert or delete the elements of the data structure from one end. That is why stack is called a restricted data structure. Okay, suppose this is a stack. You can see that three elements are there. Insert, if we want to insert another element, we will insert at the top of the stack, and if we want to delete some element, then we will delete it from the top of the stack. Okay, and this element is, it is the topmost element of the stack. Okay, next come what are the operations that we perform over stack. First one is push. Push means to add some item into the stack, that is, add an item in the stack. If the stack is full, then it is said to be an overflow condition. So if the stack is full, if we cannot able to insert any element in the stack, then it is called the overflow condition. Basically, every stack has a limit. Okay, limit means every stack has a limitation of inserting the element. Suppose there is a stack of the stack which can insert 5 elements or can store 5 elements. So we can only insert 5 elements. Okay, not more than that. The next is pop. Pop means deleting an element from the stack. Basically, it removes an item from the stack. The items are basically proposed in the reversed order, okay, which they are pushed. If the stack is empty, then it is said to be an underflow condition. Okay, so the last element which has pushed into the stack, that will be first popped. Okay, and if all the elements are in the stack are empty, that means there are no element in the stack, then there is no way to pop any element. That is called the underflow condition. I am repeating once again. If there are no element in the stack, that is, the top of the stack is at -1 position. Okay, that means there are no element in the stack. Then there is an underflow condition. We cannot pop any element. Next, top. It basically returns the top elements of the stack. That means that is the uppermost element of the stack. Next is empty. Is empty is operation is used to check whether the stack is empty or not empty. Okay. So next we will do the push and pop operation over stack. Okay. Now I am just giving an example. Okay, by which we can push and pop all the elements of the stack. Suppose this is an empty stack. Okay, this is an empty stack. As you can see that there are, these are the 0, 1, 2, 3, 4. These are the index value of the stack. The stack can store 5 values, 1, 2, 3, 4, 5. Therefore the size of the stack is 5, and this is the empty stack. Okay, so you can check. Now I want to store push. Okay, I want to push 10. Okay, so what will happen, the element will store at 0th position. Okay, so this is the top of the stack is now at 0th position. So top of the stack is now at 0th position. Next we will insert 20. So you can see that 20 is pushed over 10. Okay, next we have pushed 30. 30 is pushed inserted over 20. Next 40 is pushed and 40 is placed above 30. Next we push 50. Okay, it is put over 40. Okay, so stack is full now. As you know, the stack can able to store 5 elements, and we have already inserted 5 elements. So stack is full, or it may say that this is the overflow condition. We cannot insert any elements into the stack. Okay, next we will do the pop operation. So during the pop operation, the topmost element will be deleted. So you can see that if 50 is deleted, there will be no 50. Okay, so now the topmost element is 40. Next, I am again pop the element. Okay, so for now 40 will be deleted, so there is no 40 here. Next, we have the top of the element is at 30, so we will delete 30. Okay, so next, the top of the element is 10, we will delete 10. Okay, the stack is now empty. Now we cannot do the pop operation right now. Okay, so this is called the underflow condition. Okay, so I'm repeating once again. So basically, stack is a linear data structure in which data items are inserted and deleted at one end only rather than in the middle or okay. So this is called the top of the stack. Stack basically follows LIFO, that is last in first out or first in last out. Stack is restricted data structure. That means we cannot insert or delete from anywhere from the stack. This is the stack. We can insert and delete. Okay, and this is the top of the stack. Now what are the operations can we perform over stack? First one is push. This is used for to add item okay onto the stack. Next pop is basically used to remove the element from the stack. Next top means top of the element of the stack. Is empty operation is used to check whether the stack is empty or not. Next, I'm just doing an example. This is a stack. The size of the stack is 5. This is the index value 0, 1, 2, 3, 4. This is there is no element right now. That is why it's the empty stack. Next, we will push 10. Inserted 10. Next, we push 20. 20 is pushed over 10. Next, we push 30. It is placed over 20. Next, we pushed 40. It is placed over 30. Next, 50 and it is pushed over 40. So as you can see that the stack is full now. Okay, we cannot insert any elements again. Okay, so this condition is called the overflow condition. Now we will do pop operation. As you know that pop operation will perform on top of the stack. So top of the stack is now 50, so 50 will be deleted. Next top of the element is 40, so 40 will be deleted. Next top of the stack is 30, 30 will be deleted. Next top of the stack is 10. If we perform pop, the 10 will be deleted. So stack is empty now. We cannot pop any items from right now. Okay. This condition is called underflow condition. Okay. So this is all about stack student. In our next class, we will do the push and pass of functions. Okay. So I am requesting you to subscribe my channel. There is a bell icon on your right hand side of the screen. You can click on that and subscribe my channel, or you can visit www.facebook.com/digitalclassroom to subscribe to like my page. Okay, you will get all the notifications from there also. If you have any doubt, any clarification, you can mail me at my email id. Okay, this is my email id niladripl86@gmail.com, or you can call me in my mobile number. So thank you student, see you in the next. Dear students, welcome to my channel. In our data structure and algorithm tutorial, today we will learn implementation of stack using push operation. Okay, as you know that push operation is basically used to insert element into the stack. In our previous lecture, we have discussed all the operations that can be implemented using stack. That is push operation, pop operation, top operation, is empty operation. So in our today's lecture, we will learn push operation. Okay, we'll also discuss the algorithm for the push operation. Okay. So myself, Niladri Shekhar Pal, I am working as an assistant professor in Computer Science and Engineering Department at Greater Kolkata College of Engineering and Management. So stack can be implemented by using array or by using linked list. Actually, for static allocation, memory allocation, we used array, and for dynamic memory allocation, we used linked list. Okay. So in our previous lecture of array, we have seen how array can be implemented. Okay. So if we want to insert elements into the stack using static memory allocation, then we will use array. And if we want to insert element into the stack using dynamic memory allocation, then we will discuss linked list. Okay. We have still now we did not learn about linked list. Okay. In our later lecture we will learn linked list. Okay. So in this tutorial we will implement the push operation using array. Array is basically a collection of similar type of elements. Okay. So all the elements in the stack will be of the same type. Okay. Now this is the algorithm for the push operation. Okay. So this is the function. This is the function. Okay. So the name of the function is push underscore stack. Okay. This is the name of the function. Okay. So push underscore stack is the name of the function. Okay. And these are the parameters. Number one is the stack, next one is top, third one is max, and fourth one is item. Basically, stack is the list of the elements. Okay, top is the topmost element of the stack. Max is basically the maximum number of elements that can be inserted into the stack. That means how many elements can be stored in stack, and item is for to insert that which element we want to insert in the stack, that is which element we want to push into the stack. Okay. So this is the step 1. If top equals to max, then print stack is full. Okay, or overflow. So I am just before discussing the algorithm, I am giving you an algorithm example. Okay. So this is, you can see this is an empty stack. Okay. So these are the index value, that is 0, 1, 2, 3, 4. Okay. So these are the index values, and the size of the stack is 5. Okay. So as you can see, the stack is empty. Okay. So there are no elements into the stack. So the value of the top will be -1. If there are one element, then the value will be 0. Oh, suppose there we have inserted 5. Okay. So the top of the element will be, okay, at the 0th position. As there is no element right now. Okay. So top is at -1 position. Okay. So now, though as there is no element, so top is at -1 position. Okay. So now we will insert an element. So we want to insert an element at 10. Okay. So before inserting that element, any element into the stack, we have to increase the value of top by 1. So now what is the value of top? Now the value of top is -1. So if we will increase the value of top by +1, then the value of the top will be 0. So the top value of top will be now, the value of the top will be right now 0. Okay. Okay. So -1 plus 1. Okay. That will be 0. So top will be at 0. After that we will push this 10 at 0th position. So at first we have to increment top by +1. After that we will insert any element at that location. Okay. So as you can see that we have incremented the value of top by +1. Okay. So the value of top become -1 to 0. After that we have inserted the value 10. Okay, so the value of top is right now 0. Okay, so if we want to again push any element, so then we have to increment the value of top again by plus 1. So if we again want to insert any element, the value of top will be right now 1. Suppose we want to insert 20. Okay, so the value of the top will be 1, and after that we have to insert the element 20 into the 1 position. Okay, similarly we want to insert push 30, so we'll increment the value of top by 1, so the new top will be plus 2. Okay, so we have inserted it at second position. Again we will insert, so the value of the top will be now 3, and after that we have inserted the 40. Okay, so now we'll insert 50. So we'll first insert, sorry, we'll increment the value of top by 1. Okay, so the value top will be 4. Okay, so after that we have inserted it. Okay, so as you can see that at first we will increment the value of top, after that we will insert the element on that position. So before incrementing the value of top, we will not able to insert the element. Okay, so as you can see, the size of the stack was 5. Okay, so it can store the index value is maximum 4. Okay, so we have inserted all the 5 elements into the stack. So there are, we will not able to insert any element, or we will not be able to perform the push operation right now, as the top goes to the maximum. Okay, so top is at the maximum position. So we will not able to insert the any element to the stack. Okay, so when it is not possible to insert any element into the stack, when the top of the element will be at maximum position. Okay, so this condition is called the overflow condition. Okay, so at overflow condition we will not able to insert any element. So what is the overflow condition? When top equals to max, that means top is at the maximum position of the stack. Okay, so now let's go to the algorithm. Okay, so this is the algorithm. This is push underscore stack. This is the stack. This is the top, means top of the stack. Max means the maximum element that can be stored. Okay, and item is how many items you can, which item you want to store. Okay, so if top equals to max, okay, so if top is max, then as we know that we cannot insert any element, so there is a print statement that stack is full. So stack is full means that is the overflow condition, and we have returned. Okay, so if, so next come to the else position. If top equals to not max, then we will increment the value of top by 1. Okay. So as you know that if there is the stack is empty, if the stack is empty, then top is minus 1. Okay. So top is minus 1. So then we will insert. So insertion is possible now as top is not max. So we will increment top value by plus 1. Okay, so the new top will be 0. Then we will insert at 0th position. So this is the list of element, that is stack. Okay, this is stack. So we will insert any element at the 0th position. Okay, so we will insert any element or item at 0th position. Okay, so this is the next exit. Okay, so this is the algorithm for push operation. Okay, so as you know, as is the example, top is minus 1, we have push 10, so top becomes 0. After that push 20, top is 1 now. So after that we have inserted 20. Next we want to push 30, increment top. Top is now 2, we have then put the value of 30. After that we want to push 40, increment top. Top is now 3, we have inserted 40. Next we want to insert or push 50, increment top. Top is now 4. Okay, so we have next we have inserted 50. So we are not able to insert any more elements right now, so stack is full now. Okay, this condition is called overflow condition. So students, that is all about the push operation of stack. In our next tutorial, we will learn the pop operation. Okay, pop operation, as you know, this is used for the delete of an element from the stack. If you have liked my tutorial, you can subscribe my channel to get all the notification of my tutorial. You will find a bell icon on your right hand side of the screen. Okay, so you can click on that bell icon. Okay, or you can visit www.facebook.com/digital classroom to get all the notifications of my tutorial. Or you can, if you have any doubt, any query, you can mail me at nilajgpl86@gmail.com. So students, thank you. See you in the next tutorial. Dear students, welcome to my channel. In our data structure and algorithm tutorial, today we will learn the pop operation. Okay, so this is the implementation of stack. Basically, push and pop operations are two main aspects of stack. Push operation is basically used to insert an element into the stack, and pop operation is basically used to delete an element from the stack. Okay, in our previous tutorial, we have learned how to insert an element into the stack using push operation. Okay, so today we will learn the pop operation. Okay, that means to delete an element from the stack. So myself Niladji Shekhar Pal, I am working as an assistant professor at Greater Kolkata College of Engineering and Management at Computer Science and Engineering Department. Okay, so now come to the implementation of stack. Basically, pop can be implemented using array as well as linked list. Okay, if we want to implement the pop operation using static memory allocation, then we will use array. And if we want to implement it using dynamic memory allocation, then we will use linked list. What is static memory allocation? Static memory allocation is mean that all the memory, that is the element memory for the data elements, are occupied before the compilation. After compilation, no memory allocation is possible. But in case of dynamic memory allocation, memory is allocated for the elements or the data elements during the runtime. So you can insert extra elements, or you can insert unlimited elements in case of dynamic memory allocation. Okay, so in our next tutorial we will learn linked list. Okay, so now for we will learn the pop operation using the array. Okay, array is basically a collection of similar type of data elements. Okay, in array all the elements are inserted. Okay, or all the elements are initialized, or memory is allocated before the compile time. After the compile time, we cannot able to insert any element. Okay, so this is the algorithm for pop operation. Okay, so you can see that this is the function main pop underscore stack. This is the stack, this is the top, and this is the item. These are all three the parameter list. Okay, stack is the list, top is the topmost element of the stack, and item which element we want to delete. Okay, in our previous lecture of push operation, we have seen when the stack is empty, then the value of top is -1. So when the value of top is -1, when there is no element into the stack, so delete operation or pop operation cannot be performed when the top is at -1 position. Top is -1 position is when there is no value or the no element into the stack. So if there is no element into the stack, we cannot delete any element, or we cannot perform the pop operation. So here is the condition. If top is -1, then we will print stack is empty or underflow condition, and we will return it. Okay. So if top is -1, no pop operation can be performed. So let's go to the example. Okay, after that we will again discuss this algorithm. So this will perform the pop operation. Okay. Suppose there is the 5 elements into the stack. Okay. 10, 20, 30, 40 and 50, and these 0, 2, 0, 1, 2, 3, 4, these are the index value of the array. Okay. So as you can see, the value of top is now 4. Okay. So we can perform the pop operation. Okay. So always remember, in case of pop operation, always the top of the element of the stack will be deleted. We cannot perform the pop operation, or we cannot delete any element that is not in the topmost element. That is, we cannot able to delete 40, 30, 20 or 10 if we do not delete 50 at first. Okay. So if we delete 50, after that we can able to delete, or we can perform the pop operation on 40. Okay. So as you can see that we have performed the pop operation on 50. Okay. So now the top element is now at 3 position. Okay. So after performing the pop operation, okay, so the value of top is decremented by 1. So value of top is now top equal to top minus 1. Okay. So the value of top is now top equal to top minus 1. So the top value of top is now 3. Next we will again perform the pop operation. As you can see that the element top of 3. Okay. So top is at position 3. The value is 40. We will delete 40. Okay. So the value of top will be at 2. So top the value of 3 minus 1, that is 2. Again we will perform the pop operation. So top is as now at position 2. So top become at number 1. After that, if we again perform, then the top will be at minus 1 position. Okay. So you can see that there is no element right now. Okay. The stack is empty now. So top is at minus 1 position, or we can see that this is the underflow condition. So can we be able to perform pop operation? The answer is no. Why? Because there is no such element in the stack. So why which element we will delete? So there is no element to delete in the stack. Okay. So I am again going to the algorithm. So this is the algorithm. So if top equal to minus 1, we cannot able to delete and perform the pop operation. We will print just stack is empty, or we will just print underflow condition, and we will return. Or if the top is not minus 1, then we will item it will be stack of top. Okay. So which item will be deleted? The topmost element will be deleted, and the value of top will be top equal to top minus 1. Okay. So the value of top will be decremented by 1, and which element will be deleted? The item which is at the topmost element, that item will be deleted. Okay. So at last the exit. Okay. So I am just again doing the example. The top is at 4. So top will be now 3 as we perform pop operation. Next top is at 3. We will perform pop operation. So top will be at position 2. Again we will perform pop operation. Top is at 2. So top will be at 1 position. Next again we will perform the pop operation. Top is at 0. So now the top is at minus 1 position. So we are not able to delete any element from the stack as there is no element. So this condition is called underflow condition. So stack is empty now. So student, this is the pop operation of stack. Okay. So in our next example, we will discuss more about stack. Okay. So if you have liked my tutorial, you can subscribe my channel. You will get a bell icon at your right hand side of the screen. I am requesting you to subscribe my channel by clicking the icon. Okay. Or you can visit www.facebook.com/digitalclassroom and like my page to get all the notification about my tutorial. If you have any doubt, you can mail me at niladjipl86@gmail.com. Okay. So student, thank you for this tutorial. In our next tutorial, we will see you once again. Thank you very much.